I will be explaining about the design for the beamforming network, which is 4x4 Nolen Matrix composed of the directional couplers and also some phase shifter. So before we design this matrix, we need to design the substrate and also the grounding plane of this matrix. So to design it, we just need to add brick at the coordinate that we want. After that, we just need to adjust the x, y, and z according to the length and also the width that we have calculated in the manual calculation. And the material that we use is PEC for grounding plane and Rogers for the substrate. Then we just need to click the OK button. Once we click the OK button, we will get these results. As for the microstrip and the transmission line, I will just use the curve and line and then add to the coordinate that I want. So I can adjust the x and y coordinates according to the length that I have calculated in the manual calculation. Then click OK. After that, I need to add some other parameters to the curve that I have designed, which is the thickness and the width, and the material of the transmission line is set to PEC. Then just need to click OK. The transmission line will be added together in the Boolean expression before we can simulate it. So for the ports, the port that we use is a waveguide port, which consists of 4 input port and also 4 output port. So bear in mind that the area of the port must be 6 times bigger than the microstrip line and the height must touches the grounding plane. So there are 2 important parameters that need to be analyzed for this design. So for the second one, which is the phase difference, we cannot obtain directly in the CST as we need to insert the equation in the template-based post-processing. So we can add the S parameter that you want, and in this mixed template result, we can add the equation. For example, if you want the phase difference between port 6 and port 5 when port 1 is aside, just insert the equation of S61 divided by S51 and we can get the phase difference. So this process will be repeated for the other 3 inputs. So next is the simulation. We just need to click on the setup solver. After that, we can assign on the port that we want. So I run this design port by port so that we can troubleshoot and optimize it according to the output that we want. For example, we set to port 4. So we just need to click start button and then yes to run this simulation. So next, I will be explaining about the results. So the results can be obtained under 1D result in the folder of S parameter, as you can see here. So to get the result or transmitted transmission coefficient, so we just need to click on the results that we want, and as you can see here, this is the result at output port when port 1 is aside. So if you can see, the result is around plus minus 1 dB from the actual value, which is negative 6.02 dB. Next, we can do the same process for port 2. Just click on the results of output that we want, and we do the same process for port 3 and finally port 4. So next, for the return loss and isolation, I will just show in port 1. So it shows a good performance as it obtained the value of less than negative 10 dB, and this shows a good performance of Nolen Matrix and also the couplers. Next is for the phase difference between the output port. So this is the result after we insert the equation just now in template processing. We just need to add and then change to phase. So this is the result of phase difference between the output ports when port 1, port 2, port 3, and port 4 is on. So it shows a good agreement between the results of simulation and also theoretical, with only less than 5 degree difference between the results of simulation and also theoretical value.